Alright, so I am coming back to this after a long time. Let's see. Okay, I think I have achieved this part. I just quickly check. Oh, alright. So, Windows. Yeah, okay. So, if the recording device is connected, we cap the number we use to 10. I think I have done that. Yeah. And less than recording device count. Okay. Is this variable? Okay, recording device. And what are the references does it have? No more references? Bro. Recording devices. Alright. So, yeah, okay. So we cap. Okay, max recording devices. Huh. There we go. Alright, so we'll set max recording devices and then okay, so this part was done, right? Okay, then I have to come to this. Okay, we have event handler and set the default recording state, and then we have audio device IDs. I think I should add these right here. Okay, so extern, we can have a recording state. Recording state. Didn't I name this enum? Recording state. Okay. Right. So we have a recording state, current state. I'll define it here. Defines the current recording state. So we'll go current state equals selecting device. Right. Okay. So we have current, and then we have audio devices. Okay, for recording as well as playback. Okay. In the main function, after initializing and loading, we set the initial recording state and declare two audio device IDs, which are just integers to represent the recording and playback devices. Okay, so we have set the default recording state, we have audio devices. Alright. Shows the current state of the recording devices. Alright. Then we have audio devices. STL audio device ID. Okay, so we go STL audio device ID. We have a recording device. Can I spell? Okay. Make it extern. This is playback device. And okay. Let's copy this much. I can say other initializations, both of these are 0, 0. Okay. Then we put a switch on the current state. Okay, so in the handle events, um, I would put a switch on to current state event handling. Okay, we go to current state event handling. This is switch current state. Then we have user is selecting recording devices. User is selecting recording devices. So we have case selecting devices, case okay. So we have on key press. So on key press we check if key is down. Handle key press from 0 to 9. Okay, so 0 and it is okay less than 9. Okay, so we check if key is key press F e dot type equals STL key down. Right. If you have a key down, then we check handle key press from 0 to okay, so if the key pressed are between 0 and 9, we get the selection index. Get selection index, which is n index equals a dot keysum dot sim strk underscore 0. Okay, in the event handling loop, we have a switch statement that handles the different states. Right, so we will open the audio device, the STL get audio device name index and true. Okay, so STL get audio device name index and STL true. Then we set STL true. Then we provide the desired recording spec. Desired recording spec, and we provide a pointer to received recording spec. I think there should be, there we go, received recording spec. Okay. I think I initialized it to 0, right? Received, no, I did not. Received recording spec. Okay. Okay, I have not initialized it here, and I think neither have I initialized it here. So we'll go with what is this audio spec? Audio spec. Okay, so it's a struct, right? Okay. Let's set everything to 0. Okay, I think this means value initialized. Okay, so this is initialized by value. Okay, then we pass in this receiving or received recording spec. Okay, received recording spec, and then we pass in STL audio allow format change. Okay, so STL audio allow format change. STL audio allow format change. Alright. Okay, so we have if the user pressed a valid index key, we then specify the recording spec. Okay, so it gets the names, right? STL get audio device name, we provide an index. Okay, alright, so recording. Okay, so recording device count is here, and these are arranged by index. Okay, got it. So you pass in the index and that, right? Okay, so first we initialize the audio spec with STL0. Always initialize memory before using it. Okay, always initialize memory audio spec. So should you do the same, STL0, right? Desired audio spec. So I can we create an audio spec and it takes an STL, right? STL. Okay. So I can initialize them. Initialize. Okay. So we have declare and initialize. So we can go STL0 is received recording spec and then received playback spec. Alright. Initializing memory with all zeros. But shouldn't we pass it? No, we don't pass it by the type audio spec, right? But it is not really. Format channels, we have simples. Okay. Okay. We have channels, frequency, format, simples. Alright. So we set the frequency 44.1 kilohertz, which is CD quality. We're using 42-bit floating point format for the data. We have two channels since we want stereo. Samples are to set 4096 because that's a pretty standard size. And lastly, we get with the audio recording callback. Okay. So with the spec set, we call STL open device and pass the recording device name. The fact that we want a recording device with STL true. The spec we want to have. A pointer to the spec we get back from the driver. And lastly, a flag that says we're okay with STL open device, giving us a different format than we requested. Okay, then we check define. Okay, device failed to open. We have if recording device ID equals 0. Recording device ID. Okay, so we're still in the if. Okay. We go. Then we have device failed to open if recording device ID equals 0. Okay. Okay, I do have an error. No, I don't have an error phrase here. So I'll make an error. Fail to current state error. Alright, yeah, I should not reduce error here. So we go. We log info. We log info that failed to open recording device. Hold up. Log info. It writes info, right? Maybe I can log an error. Right. Log error. It's log error. Yeah. We can log error. File find. Failed to open. I have failed to open recording devices. Failed to open recording device. And we provide an STL error. STL get error. Okay, then we update the texture, update the text on the texture, on the prompt text. So we have texture underscore load from rendered text. I think if there's such a, yeah, load from rendered text. So we pass in the texture, the window, the font. Okay. So we pass in the texture or the prompt texture. Okay, so pass it in as is. So we go with prompt texture, window. What else? Window font. Okay. Font and go failed. Then we have failed to open recording device. Fail to prompt right. Okay, failed to open recording device, and then we pass in text color as well. I hope text color is there. I think, yeah. Okay. Then we have and set the current state to error. Can't find current state. Well, I have current state. Oh, because I need to remake. Shift P equals tags. Yes, right here. So it should have. Still can't find current state. There it is. Okay, anyways. Okay. So else device opened successfully. Okay. So default audio spec. So we get the desired playback spec. Okay. So we also get a playback. Okay, if we get no device ID. Okay, if we get no device ID, we got an error. If the device opens successfully, we create a playback spec that's mostly the same as recording spec. The major difference is that it uses the playback callback instead of the recording callback. Okay, opening the playback device is mostly the same. For this tutorial, we don't care which playback device we get, so we pass in null to grab the first available one. Secondly, we pass in STL false for the second argument to open up a playback device instead of a recording device. Okay. Okay, so here the second arg STL true suggests we want to open a recording device. Okay. We move on to else. device opened successfully. Okay, so we have a device that opened successfully. When we create, okay, now we create a spec. Okay, now we create a spec for, now we create spec for print state for playback device. Okay, so we go audio spec, decide playback spec, stl audio spec, desired playback spec, then we have stl0, desired stl0 desired spec. Okay, then we have desired playback spec dot frequency. Let's just copy this, equals 44100 dot format is audio 32 dot channels equals to then we have samples (4096), and finally we have a and finally we have a callback. Okay, so desired spec dot callback equals this guy over here. Where are you? Yeah, there we go. Okay, now we open playback device. Playback device, we have playback device ID. I think I do have that right. Playback device ID. Playback device ID equals stl open audio device, and we pass in a null. We don't care which one, just grab us the first one, false, so that it knows that we want. Okay. We have desired playback spec. Okay, we pass the address on desired playback spec, and then we have received playback spec. There we go, received playback spec, and finally we want to stl audio allow format change. stl audio allow format change. and we close it. Okay. Okay, so if we get no device ID, we got to an error state. If the device opened successfully, we create a playback spec that's mostly the same as the recording spec. The major difference is that it uses the playback callback instead of the recording callback. Opening the playback opening the playback device is mostly the same. For this tutorial we don't care which playback device we get, so we pass in null to grab the first available one. Secondly, we pass in still false for the second argument to open up a playback device instead of a recording device. Damn. Bro, this is one hell of a case. Okay. So you go. Device failed to open. If playback device ID equals 0, report error. Okay. Okay, this is all a switch case. Right. Alright.